Either going to get through this in 15 minutes if it just flies through, or it's going to take the whole, I got to guess, till about 12:45, 12:50, something like that. Yeah, okay, cool. And I'm fine with questions as we go. I prefer that. So what we want to do is make sure we coordinate and get you a mic before you ask the question. I'll help you try and remember that, if you'll help me as well. So let's get started. Who am I? I'm a lucky guy. I'm not sure I'm quite that lucky. I think he loses both wheels. Watch that. Unbelievable. I don't know if that's a doctored video or the truth, but that is amazing. But I feel like I'm a lucky guy because I'm more than just, somebody who works at a company, right? I'm a husband of 43 years, going on 43 years. I feel like that's an accomplishment these days. But before you start your age calculations, how old is he? I got married when I was 12. So that has to calculate in, right? But one of these facts is not true, so you get to decide. Okay. I'm also a father. Lucky to be that. Have one son, Mark. He lives in Florida with his family. He's an entrepreneur. The entrepreneur gene skipped me. My father had it. He was always an auto mechanic and built things and ran his own garage for most of his life. Skipped me. I worked for the company. Mark tried that for a little while, but then got that entrepreneur, thing going. And that's what he does now. He's in IT. We have that in share, so that's a lot of fun. So somewhere along the way, he became my best friend. That's part of the luck part of this. I mean, it's so cool to have a son you're proud of who, does you good, but he's my best friend. We spend time just talking, shop, and other stuff, so it's fun. And he's blessed us with 2 granddaughters. So I'm also a grandfather. I had no idea how much fun it would be. I love being a grandfather. It is amazing. And it's not the spoil them and send them home thing. It's just fantastic. I don't know how to describe it. They live in Florida. They lived in Seattle for 5 years, and I made 6 trips to Seattle in the time they lived there. But now they've relocated to Florida, which is only an 8-hour drive, so much better. Jada is my oldest. She will soon be 9. I can't say she's 8 because she corrects me immediately because on July 4th she'll be 9. I'm almost 9, Grandpa. Yeah, okay, got it. We love storytelling. These are the things that I have in common with Jada. And so for 4 years, when I see her, we have to continue this ongoing story that we've made up about 2 fictional, little girls named Jenny and Tammy. By the way, her sister's name is Tara. So it's pretty obvious what's going on here. They live in England and London, but they travel the world doing stuff. And we make up stories, and it's what they like to do. And she even, after one of our storytelling sessions, went home and wrote a book. Made her own story up, wrote a book, annotated it. It was cool. Tara, she is soon to be 7, May 30th. She'll be 7, so I can't say she's 6. What we have in common is we love to laugh and joke and kid. And she tells me that, Grandpa, I am so funny, sometimes I make myself laugh. That's how funny she is. She knows I like to play golf, and she told me this golf joke about a year ago. I can't imagine she understands it, but she liked the fact that I laughed, and so that's our joke. So the joke is, why did the golfer wear 2 pairs of pants? The answer is, in case he gets a hole in one. All right. And she thought that was hilarious. I don't think she had any idea, but she thought that was hilarious. And we both think that Alexa needs new jokes. She does not get jokes soon enough, and you can run through the whole inventory of Alexa's jokes pretty quick. Although there's also Chuck Norris jokes, which I enjoy, that she doesn't get. So, and we have this thing we do, and they're coming next week for a visit. And so next Friday I'm taking off. And if there's a kids-friendly movie out, we go see it. It's just me and the granddaughters. And so Boss Baby comes out next Friday. So we've got a date. We go to lunch. We go to the movie. We have fun. They like going to the movie with Grandpa because they can go to the concession stand and get anything they want. And I don't go to the movie a lot, and I had forgotten just how expensive the concession stand is. A lot more than the movie itself, but it's worth it. So proud to be a grandfather. That's who I am in that regards. But I also have to make a living. So I'm an infrastructure guy, have been for a long time. This is my second career. I'll talk about that here in a sec too. I like my job. sometimes I feel unique in that I go to work, I enjoy what I do, and I get paid money for it. So this works out really well, and I consider that lucky. I work at Unum. My title is a cloud solutions engineer. So I'm on a team that deals with cloud, and we'll talk more about that here soon. As I mentioned, this is my second career, because remember, I've been around for a while. My first career, hint, was running Radio Shacks. I ran Radio Shacks for 15 years in 3 different states. In fact, I opened the Hamilton Place store when the mall had its grand opening. And literally, we still had places in the store that had wet paint when we rolled the gate up on that grand opening day. What a trip. And working retail is something else. And that was in Radio Shack's heyday, before it started going down a road they couldn't come back from eventually, which is, they're still going that direction. I got introduced to computers in 1980. This is before I worked for Radio Shack. I went to Radio Shack because of my interest in computers. Lived here, actually lived in Cleveland. Went to the Radio Shack at Eastgate, when Eastgate was thriving. There was no Hamilton Place. In the summer, put one of these babies on layaway, paid for it throughout the rest of the year, got it at Christmas, and learned to program. And this is a TRS-80, don't call it Trash 80, that still makes me wince. This is a TRS-80 Model 1, 4K of memory, 40 columns on the display. That tape drive is how you store your data. And that tape drive, of course, is just a cassette recorder. But it was a lot of fun. As I mentioned, 40 columns, 4K. My first hardware hack was upgrading that to 48K. So there's this expansion bay that you can sit it on, and it comes with some memory or no memory. And then I bought a third-party kit that I could plug these chips in, and they weren't your typical DIMM socket chips. They were the normal chips that looked like a spider with 12 little legs. So I took it all, and all this stuff was expensive, incredibly expensive. However, I went this route because I could afford this. I could not afford an Apple. Apples were out of my price range at the time. So I bought the kit, I had my chips, I plugged them all in. It didn't work, distraught, called their tech support, worked through it, and what I hadn't done, because I'd never played with, chips before, is I hadn't pushed them down far enough to get them all the way in the socket. When I did that, everything was cool. I learned to program by subscribing to a magazine called 80 Micro. Back in that day, of course, magazines were a big deal. 80 Micro came measured in hundreds of pages. There was 80 Micro like that, there was Byte like that, there was Computer Shopper like that. It was amazing. I learned to program by typing in a program called Dancing Demons. That's the actual Dancing Demon right there on the TRS-80 Model 1 screen. In Tandy Basic, your strings were limited to 256 or 255 bytes. The first byte, had to do with how many characters were actually in your string. And the way that this Dancing Demon worked, because you couldn't move the pixels around fast enough in BASIC, but you could have direct access to the memory of the screen. And so if you could do assembly language, you could directly access the memory. I wasn't an assembly language programmer. Most people who subscribed to 80 Micro were not. But we could type BASIC, and so what they did is they figured out how to put the assembly language instructions in the 256 bytes of the string by holding a particular key and on the number pad typing in the value of that character, and then the next one, and then the next one, and the next one until you got up to 255, and then use the poke command to put that in memory. So once you got all those strings built, then you just had to loop through and poke those strings into memory, and the memories mapped to the screen, and that guy would dance. I mean, it was amazing. And when I got that to work, it was the greatest thing. It did not come with sound, but it had that, because the computer didn't do sound. But they got it to do sound, and this guy would tap dance to a tap dance tune. And the way they got it to do sound, I thought was pretty amazing. That tape drive, that cassette drive, had an 1/8" jack on, or a 1/8" jack on the end of it. You plug into, one end is plugged into the computer, the other end is plugged into the tape drive, and it feeds the data out there. They figured out how in assembly language, again with poke statements, to get it in there. to turn that relay on and off fast enough in the right sequence to make sound. So that's how they were able to simulate some sound, and that was incredible. Thoroughly enjoyed that. Hours and hours and hours. I apologize, I'll be coughing some. I'm on the tail end of a cold and past the cold, but I have the cough still. I started a local tug, that's a Tandy users group, and ever since then I've been involved one way or another in users groups, and usually multiple ones, as is today. I'm involved in multiple meetups. Today they're called meetups. At one of our tug user groups, a guy came and started trashing our TRS-80s because he had this newfangled computer called an IBM PC. And he even had a floppy drive. And it came with Pascal. And he was just totally, it was the thing. So we decided that at the next tug meeting, it was monthly, we would have a contest. And the contest would be to write to the screen counting from 1 to 1 million. Now, as I said, I usually have an ulterior motive, so I stacked the deck on this big time. I had been playing around with the assembly language well enough that I finally got the bug, and Radio Shack finally came out with an assembler and learned the assembly language. And so what I did is I wrote machine code in assembly language to count from 1 to 1 million on the screen. It took a second or two, because all it is 1 to 1 million in memory on the screen. He wrote his in Pascal, and so he brought his big old, IBM PC the next time. He fired up Pascal, it counted to 1 million, took 3 or 4 minutes. I counted to 1 million in a second or two. It was a wonderful time. This is the follow-on to the Model 1. By now, I've gone to work for Radio Shack because of my interest in computers. I used to bring my Model 1 to the job I had at the time, which is a night auditor at a hotel, on third shift, and get that 80 micro magazine and lay it out and type it in for 3 or 4 hours because I could do my job in a couple hours. Then it was just nursemaiding, the drunks coming out of the bar and the, calls from the help from the rooms or whatever. So drunks coming out of the bar, a Radio Shack was coming to town. This was Poplar Bluff, Missouri. And the manager and assistant manager frequented the bar while they were setting the Radio Shack up. And so they come by one evening, and there I am typing on one of their computers. And the next week I started at Radio Shack. So that worked out well. I sold my first TRS-80 Model 3, and it had floppies. And eventually the Model 1 got them as well, but this came with standard. And they were double-sided 5¼ inch floppies. They weren't your standard run-of-the-mill. They were top-notch. Sold it to the doctor. He was single, had lots of free time, wanted something to do with the computer. And he said, if you'll help me do the thing I'm about to tell you, I'll buy a computer. I said, I'll help you do it because I'll learn and I'll sell a computer. And we're talking $3,000 for one of those, right? Now, it had an 80-column display and 64K of memory, so it was a hoss. What we did is we wrote a program to beat the local radio station bingo game. So the deal was that to drive business, you could go to vendors who had these bingo cards, the actual bingo cards, a deck of them, and you could collect them and go home, and then at certain times on the radio, they would play bingo, and if you got bingo, the first one to call in was the winner, right? So in a week or two, he went to enough vendors, enough times, he got all the bingo cards because we realized that there was a limited set of them, and it was a couple thousand. I wrote the program using a database in BASIC. He typed them all in, and he got to the point where he could win every time. He wouldn't call every time because eventually they got onto him. He was able to, and of course what he was winning was 2-liter Cokes. I mean, it's not like he was getting rich off of this. He was just enjoying beating the game. Then they switched to a serial number game on dollar bills. So, yep, he went to the bank, got 500, dollar bills, typed all those serial numbers in. They read off a portion of the serial number. If you got that, and you call in. And of course, he didn't have to physically rifle through those. He knew he had them. And by the time that he had to drive to the radio station, he looked up his bingo card or he looked up his dollar bill and away he went. So we had fun with that. They did finally figure it out and quit when they recognized his voice taking his call. They would just hang up on him. So We didn't play that anymore, but that was fun. And I learned a lot. All right, then I switched careers and became an IT professional and a HR manager for a short time. Hated that part of it. Having to deal with people like that computers are a lot more fun to deal with than people in that regards. Went to work for a small company in Ooltewah, manufacturing firm, doing IT, all their IT and their HR stuff. So my introduction to Unix was interesting. They had a Xenix, I've got Xenix there, system that, and Xenix is an early Microsoft, it was SCO and then Microsoft bought SCO, I forget the whole drama, there was drama. And this was a payroll system that had, operated on Xenix, and its machine was dedicated to that. And so not long after I showed up and was, doing my job, but I wasn't working with that system. That was a closed system. I didn't have to worry with that. I was working with other things, manufacturing, interfacing with manufacturing stuff, that kind of thing, writing time card programs, all those fun things. It broke one day, and they couldn't do payroll, and there was going to be a problem on Friday. This was like, Tuesday. So I went to the bookstore. That's before you could get on the World Wide Web and, Google it. Went to the bookstore, got a book on Unix, read enough to realize that probably the problem was permissions. And I learned enough to say, go to root, chmod-777. It fixed the problem. I was a hero. Payroll went out. We bought a different payroll system. I was so glad because I'd had no idea what other things I'd caused to happen with 777. But that was my introduction to Unix. Then I got to play with Clipper, summer of '87. That was a database programming language that was based on DBase 3. I don't know if anybody remembers that or not. And some of the fun stuff I got to do with that was I tried to have a little side business. I've always had more than one thing going on. And so I contracted to Lee College to write a couple things for them. I wrote their first chapel attendance tracking program, which the kids did not like at all, because now they, had to go to chapel, and they knew whether they went to chapel or not because they had IDs that they put a barcode on, and we had these barcode readers. And the way these barcode readers worked is they go beep and store it in the memory, and then after the whole thing is done, they go and they dock the barcode reader, and all that data gets downloaded to this application, and then it calculates who was at chapel and who wasn't. And we also did a similar thing for like a debit card purchase system in the cafeteria. That was fun, and remember we're working with 64K of memory because this is the time frame is when Bill Gates said no one will ever need more than 640K, talking about the IBM PC, right? Because it could address that much. But I could take these Clipper programs that were huge. They were like 320K, which is huge in that time. And there were some neat libraries that would take those big programs and do a little bootstrap called TSR, a Terminate and Stay Resident bootstrap, and allow you to take that program and put it off in other memory, which is not your main memory. It was just extended memory. And when you hit the right key sequence, it would pull it into main memory. So it worked out pretty good. And then in 1993, I went to work at Provident. In 2000, we merged with Unum, and we're called Unum now. It was cool. I got to work with my son. The reason I got introduced and got a job there was because my son was working there. And that was his short time to work for the man, and then he decided to go and be an entrepreneur. So, almost done with me. I'm currently a cloud infrastructure engineer at Unum. On the cloud enablement team, have been going on a year. We'll be a year this summer. Our job is to get us out of the data center business. Unum is an insurance company. They're not an IT company. They want to sell insurance, and their product is new ways and new offerings from an insurance perspective. Disability insurance, we're into dental, we're into vision. This is where you can heckle me because I'm not an insurance guy, so I usually get this part wrong. I'm an IT guy. But we want to get out of the data center business, and we have a plan to do that, by 2021-ish. And we have 3 data centers. We have a small one in Chattanooga, the remnant of what used to be a large. We have a large data center that we operate in Columbia, South Carolina. And then we have space we lease out of a data center in Alpharetta. We want to get out of the business of operating those data centers because we're an insurance company. our executives have bought into the cloud, and so they think we can put it all in the cloud, so that's what we're working on doing. We know that we have to start with the servers we have to have a place to go. So we're starting our cloud adventure with IaaS. We'll progress to PaaS. We're already doing some SaaS, right? So IaaS is infrastructure as service. PaaS is platform as a service. You just code to the platform, and it runs it for you. It scales it for you. Everything is happy. And then SaaS is, you buy the service. So we want to move our servers to the cloud. Is our purpose for IaaS. For PaaS, we want to change the way we develop apps, right? So we've got to start thinking in terms of how we develop for PaaS, and then we won't have to worry about the infrastructure part of it. And we have a mantra from our CIO that's buy versus build. So if we can buy an application versus building it, we will. And this is for the stuff that's I think I've got it here. Yeah, let's go back. I've got that on another slide, but for applications that aren't our bread and butter, line of business applications, we want to buy those because those don't bring us any value. And having to write and maintain those don't bring us any value. So to have a competitive edge in the insurance market, they want to put their resources, and I think rightfully so, on writing applications to sell our product in new and various, and service our product in better ways. So that's, so we have this mantra that says buy versus build and cloud first. So we try to measure everything according to that, and then we do whatever we need to do. All right. But I have an aspiration. When I grow up, I want to do something different. I like to teach, so I'm up here doing this today. I like to program. I'm an infrastructure guy, but I used to write a lot. After the manufacturing, I came to Unum. I got involved in an AIX system, which is IBM's version of Unix, and then Linux. I brought Linux into Unum, and now we have about 1,000 Linux servers. And so I really like, Unix, Linux, those kinds of things. My programming on AIX was Perl, and it was great. I could do all kinds of stuff that was harder to do in Bash. So Perl to me was just a better Bash. Problem is like Perl, is a month later it's hard to read your own Perl code unless you've just commented it, really well, or just are disciplined to write it in a very rigid style. So when I got to Linux and found out about Python, I went in that direction because I can read my Python usually a month later. And there's a whole bunch of libraries for it, so that's cool. I like to golf as well. So I think that the job I'm looking for is my classroom would be up to 3 students. I would teach programming from the golf cart while playing around the golf, and I'd like to do that in Florida. So if you know of a job that fits those, let me know. I'm looking. All right. What I plan to get out of this talk, and then we'll be done with the part about me. I'm here today as a challenge to myself because you folks make me nervous because everybody in here is a lot better programmer than I am. But, I stick it out there when I can. And I'm trying to get my presentation game up a notch, and here's why. So to do that, a week ago I presented at ChawDev Python, and we talked about object-oriented programming. Today, and I don't think we quite got 50, but I think we're close to 40. I did a quick count. I thought I would, get up here and talk to this many people, of people who make me nervous. And that would help me because in May, I'm going to Red Hat Summit, and I get to present to 500. So I'm hoping that by the time I get there, I'll be a better presenter. So enough about me. I bet you're glad for that. What I hope to get out of what I hope you get out of this talk is a better understanding of IaaS, the Microsoft Azure way, right? So we're going to focus on IaaS, building servers in the cloud on Azure. And by the way, the Microsofters do pronounce it Azure, so I assume that's correct. And I would like for you to see also a working demo of a third-party tool that we use to, once we build the server, to do something with it. The server's got to get ordered. It's got to get built. It's got to get all the special configuration that a Fortune 500 company that has a corporate security officer wants it to be secure so that we don't get in the news about a breach and for all the wrong reasons. So there's a whole bunch of stuff has to be done to a server after it's built. So we incorporated a third-party tool to do a lot of that, and we blended them together. But first of all, why Azure? Clearly, AWS is the market leader. I've got the Gantt chart from Gartner on the next slide, and there's no competition, right? But Microsoft is clearly in second place. There's no one close to them either. We're talking, about IaaS. We're not talking about the whole, cloud offering, but from an IaaS perspective. And I've been impressed with their offering. It's solid. And you would think it's only Windows, but they claim that over half the VMs that they host in their data centers are Linux. And I suspect that's true, because it's equally as easy to put Linux, I think easier, than it is to do Windows in their own cloud. They're making great strides. It's not your mama's Microsoft anymore. They really have made a lot of changes with their new management, and a lot of things are different. However, AWS is such the gorilla in the room, I don't think anybody's going to catch him anytime soon. But it's interesting where this whole thing is going, and I'm enjoying the ride. Unum is a large Fortune 500 non-IT company, so we're trying to focus on doing the things that bring us business value, not focus on building things that we can buy that are not our line of business apps. We have about 10K Windows desktops, so we have a lot, right? So in those data centers I talked about, the desktops are on the desktops throughout the company, right? And we've got people in a big campus here, a big campus in Portland, Maine, not Portland, Oregon, a big campus in Columbia, South Carolina, smaller campus in Worcester, Massachusetts, and I think field offices in almost every state, if not every state. Yep. Altogether, approximately 10,000 Windows desktops. So obviously, we're a big customer for Microsoft. We have about 4,000 Windows servers. Most of those are all on VMware. We have 3 mainframes. We're an insurance company. Apparently, you can't be an insurance company and not still have mainframes to deal with. Those are in Columbia, South Carolina, except for a disaster recovery one that is someplace else. And we've got about 1,000 now Linux RHEL servers. Those are VMware as well. So those are the things we've got to put in the cloud over the next few years. This is that Gantt chart, or they call it a Gartner Magic Quadrant. Now I get to use my new fancy pointer. Amazon Web Services is way up there, but look, Microsoft is in the leader quadrant now, farther down, but in the leader quadrant, and everybody else is someplace else, right? Google Compute Engine, which is their IaaS offering, is here in the Visionaries quadrant, and then everybody else is in the niche players. I bet they hate that. But there's some names in there: Rackspace, CenturyLink, IBM, VMware. They're characterized as niche players. This is as of third quarter last year. So it's a little dated, but I think it's pretty accurate. All right, so we're still on why Azure. Unum is a big Microsoft company. We have an enterprise agreement because we do so much business. So we are a big fish for Microsoft, and we're not for AWS. So as a result, we have significant discounts on all Microsoft services, including Azure. The end result is we can do IaaS at Microsoft for about 40% less than we can do IaaS at AWS. So there's just the financial argument is we can't get past it. So we're going to start with Azure, get that going in the direction we want. We are taking a look at AWS as well. We want to get our toe in that water, but we got to figure out a way to get those discounts in there while we're a small fish, right? So we'll see how that goes. What we're trying to accomplish with this whole thing, as I mentioned, if we can stamp it accomplished by 2021, is to get out of the data center business, right? To buy versus build, to go cloud first. We're going to use IaaS to move our current servers to the cloud. We put a stake in the ground in January and said, no more new servers built in our data center for our dev environment. Build those in the cloud. So we feel like we've stopped the bleeding in that regards. Now we've got to figure out what to do with those other environments, and we're probably going to have a private cloud for production, but it's all going to be in some sort of a cloud eventually. So we're going to start with no more new dev in our data centers, put them in the cloud. That's what this talk is about today, is how we're doing that. This summer we'll be migrating the Chattanooga data center to the cloud, so that'll be interesting. Once we get that cloud thing going, then we're going to turn our attention to PaaS, because we're going to have to start getting developers thinking in terms of using services that someone else maintains that we don't have staff to maintain to be able to write their apps against. And that'll change the way we develop apps. And then for SaaS, we're already well along the way of using SaaS for our non-line of business applications. Like, for instance, we're a ServiceNow customer. That's ITIL. That's your change control, your configuration management, all that fun stuff. Workday is all our HR stuff. And then our sales, we've got Salesforce as well. So those are all SaaS offerings, completely. Somebody else is running the whole application. We don't write it, we just, consume it. All right, so now let's get into the nitty-gritty technical stuff. I think we're doing pretty good on time. I'm going to have to step it up a bit. This is what the portal looks like in Azure. I'll show you that here in just a second. The portal, this version of the portal is using something called Resource Manager, where things can be deployed and maintained as a group. A year or two ago, they had the classic mode, and things were not maintained as a group. This is much improved. If you go and do Azure, start here. Don't try and start with classic. I think it's hard now to start with classic, so you'd have to go out of your way to do it. Point and click cloud services. All right, so let's demo building a Linux VM. And I'm going to have to log back in here because I've talked too long. Bear with me. And this is the live demo part that won't go right, so, send me some good vibes. All right, whoops, I knew that would happen too. All right, so this is what the portal looks like. And if I go to the dashboard, it looks like this. If I wanted to build a VM through the portal, and this is not the way we build them because these are one at a time handcrafted, right? What I do is I go to what's called the marketplace, and I'm going to build a CentOS box. So I'll look for offerings in the marketplace. It's their storefront, right? For CentOS, and there's a 7.3. Let's build one of those. We're going to do it as Resource Manager. As I mentioned, always use Resource Manager. Don't use Classic at all. All right. We need a name for our server. I'm going to build a cheap one. I'm not going to use SSD. We'll use a username. Doesn't matter if I spell this stuff right. I'm going to use a password instead of a key just for this demo. I do have to type this twice the same, so bear with me. And there are rules. I don't think I got it, but we'll see. Oh, yay. I'm going to put it in that subscription. Subscriptions are sort of like a billing container. Everything in this subscription gets its own bill, so forth and so on. I'm going to put it in an existing resource group that I played with earlier. Not surprisingly, called RG Chadev. All right. So everything looks good there. Moving on. Now I get to decide some things like what size do I want. So these are called flavors. This is CPUs, cores, it's speed of disk, it's network speed. There's all kinds of things that influence this cost. This is the retail cost of these for, because I've got to move along here. I'll use standard storage. There we go. That storage account is fine. I'm going to hook it up to an existing VNet that we have out there. I could create my own VNet, so I'd have my own VPC, but I'm not. I'm going to use an existing one. We'll put it on that subnet. I'm not in this one. I'm not going to let it get out to the public internet. This is only going to be addressable from inside the company. That's a security concern, right? All right, and I'm going to put some firewall rules, pre-baked firewall rules on that NIC. I'm not going to add any extensions. Extensions are things like diagnostics, or in the case of a Windows server, you can put extensions on there to do WinRM so you can remote, control it, those kinds of things. I won't do anything with high availability. I am going to enable boot diagnostics. One thing that AWS does not do, and neither does Azure, but people like DigitalOcean have figured it out, is you don't have a console. So you can't SSH to this Linux server when it's done. I mean, you can SSH to it. You can't get to the console so you can see it boot up and the stuff scroll by. Same for Windows. You can't get to a console and see it boot up and the stuff scroll by. After it's up, you can use RDP to get to it. So the boot diagnostics is sort of like the second best thing. It takes screenshots. It'll show you the boot log, stuff like that. And then we're good. And this is just, detailing what I did. I press OK. I go away and get a cup of coffee and some more stuff. And in about 10 minutes, I'll have a Linux server. All right. So that's how you build it the, one at a time manual way. Oh, there we go. Another way to build it is with a tool called the CLI. I'll talk about this. I won't demonstrate it since I'm running short on time. The CLI is a command line interface. The current one is written in Node.js. Let me get a head. Yep, perfect. So it's cross-platform. It runs on Linux, Mac, and Windows. And basically what it does, it's a command line way to drive the existing Azure API. They have a rich API set. You can do everything that you can do in the portal. In fact, the portal uses the API. So everything that I just did was driving the API but through a UI, right? The command line drives the API, but through command line, stuff. I have my email address at the end of this. If you want this presentation, drop me an email, and I'll be happy to share it with you. I don't have time to demo the commands. Sorry about that. All right. They have, and I'm excited to see this, a new version of the CLI that is they call it preview. They don't call it beta. They call it preview. That looks good, and it behaves more like a traditional command line Linux kind of an app. It's written in Python. It's quicker than the Node.js app, so we'll be moving to that when it's no longer in preview. Because in preview, it doesn't have the full feature set. Once it gets out of preview, it's got the full feature set. It's a Python app. It too is multi-platform. It feels like a native app. You can take a look at that. Maybe that's something I could do at a lightning talk. And I think we got one of those coming up. All right, so you can build this. You can use PowerShell too. Problem is, and by the way, you can use PowerShell because after all, this is Microsoft, right? It does everything the CLI, both versions do, and a few little extra tricks. However, you can get the other versions to do everything. You just have to work a little harder at it. But I'm not a Windows guy, but this is something that I need to learn. But my mother said, be nice, don't say ugly things, so I'm not going to. All right, it is Microsoft. So let's talk about how to build ARM templates. That's the way we deploy them. ARM templates are JSON files that describe the resource you want to build. So it says, what compute resource do you want? Oh, I want an image from the marketplace of CentOS 7.3. How many disks do you want attached to it? Here's the information about the disk. I want those disks to be encrypted with data at rest. Check the box. And you check the box by saying this value is true, right? So you build this ARM JSON template, and then you can deploy that. You can deploy that ARM JSON template several different ways. You can through the portal, from the command line, straight from GitHub. There's a great GitHub repository called Quick Start JSON ARM templates. Just Google it, and there's hundreds of templates to do all kinds of stuff, not only for IaaS, but for PaaS as well. So, and it too is driving the API, so it's really kind of cool. And third-party tools, which is what we've done. And I'm going to get through this, but I'm just going to have to skip the demos. This is an empty, but the values you need in an ARM template. You can get away with not doing outputs, and you can get away with not doing variables, but I've never seen an ARM template that didn't have variables. So you use those sections, and they're aptly named. Parameters go in the parameter section, and then whatever you're deploying to can use those parameters to query for inputs. What do you want your server name to be? That kind of stuff. The variables are just used elsewhere in the resource section of the ARM template. There is, some rudimentary scripting capability with ARM templates. They do some substring stuff, and it's a very limited, language, but it's kind of cool that you can do that. In case you couldn't see that, and there's a link to, Microsoft. Let me just show you this real quick. Microsoft has some pretty good documentation out there, and their documentation is taking this form now as wikis. So you can go here, and this puts you in this whole flow at the point of authoring resource manager templates, and these things are maintained too. Look at that, 1.3.2017. So, you know, kudos to Microsoft. Like I said, it's not your mama's Microsoft. All right, let me get back here. All right. We have ARM templates that we're using for the VMs that we're building. We create VMs from Marketplace Images for 2012, Windows 2012 R2, and RHEL 7.2. We're using the RHEL version because we're paying for support so that, you know, we can make sure we've got somebody to call and say, help. Although we hardly ever call Red Hat for RHEL, because you can just Google it and figure it out a lot quicker. But I flat worn out the support for CloudForms. We've had to have a lot of support for CloudForms. Our ARM template creates a second disk so that you have a drive D for your Windows box. You have, you know, a data disk, you know, ish for your Linux box. It creates a NIC and signs it up to that same VNet and that subnet with that NSG as I manually did. It creates storage accounts that are encrypted with data at rest. One for the VM, you know, blobs, the VHD, and its hypervisor. The hypervisor up in Azure is Hyper-V. So obviously, because it's Microsoft. It creates an availability set and puts them in an availability set. Just allows you to say, Microsoft, everything that's in this availability set, don't reboot these at the same time. If you're going to do some maintenance on the hypervisor that requires rebooting, don't reboot anything in this availability set at the same time. Spread that out. That way you can get higher availability on your apps. We enable the boot diagnostics. We install the diagnostics extension. This creates a database in that other storage account that you can then query about CPU usage, memory usage, disk I/O, you know, all kinds of cool stuff. And in the case of Windows boxes, we do install that WinRM extension. As I mentioned, there's, you know, the templates out in GitHub are cool. Proof that they exist. And they just go on and 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 on. So there's a lot of them. And you can deploy right straight from there on some of them. There's a little button that says deploy to Azure. It's kind of cool. All right. I had planned to demo doing a simple RHEL. I'll show you the template here in a sec. I'm not going to have time to do it. One more time, then I'll quit saying this. It's not your mama's Microsoft. This is an open source programmer's editor from Microsoft that's halfway decent. You know, it's called Visual Studio Code. It's open source, it's cross-platform, Linux, Mac, Windows. It does a lot of different languages. What I like it for, because I'm a Sublime Text user, and you know, will be until you pry it out of my cold dead hands, right? But I switch over here when I'm working with ARM JSON templates, because I don't know if you noticed or not, but in that ARM JSON template, there was a schema section, and that schema pointed to, you know, a schema out on the web. This will load, if you tell this editor you're doing ARM templates, it will load that schema, and now you have syntax checking of your ARM template and IntelliSense. So yay, that's a cool thing. And if we wanted to see what that looks like this. I'll put an ARM, maybe I'll put an ARM JSON template in there in a minute. Oops, too far. All right, where are we at here? So now you know how to take an ARM JSON template and build a VM, but that's only scratching the surface of what we need to do. We need to, you know, have a way for our customers to order that. We need to have a way to track the whole process. Once it's built and Azure is done, then we need to layer on top of it a whole bunch of stuff in the case of both Linux and Windows, more so for Windows. All that security stuff. They might want the web server, they might not. They might want SQL Server, they might not. We want to give them all of those options because we're not going to put everything on every server because of licensing, right? So we need a way to manage that. There is a product or an open source project called MangeIQ, which is a third-party cloud management tool. Works very well for IaaS. It's weak in PaaS, but we bought it for IaaS. We bought it for a couple of reasons. It's strong on IaaS. That's what we needed. You can also buy it because it's a Red Hat product on a subscription basis because they don't license the product to you because it's open source, right? But they sell you support. That's their business model. So we buy support from them on a subscription basis, which is an annual cost. So we know that if we decide tomorrow not to do this anymore, we can switch off. So I'm going to finish up here. The upstream project is called MangeIQ. The downstream commercial product is called CloudForms from Red Hat. We use it for service catalogs. It allows us to create a catalog of services, right? So we have a lot of subscriptions. Each subscription is aligned with a business unit at our company. Each subscription has its own catalog, and the catalog items in there are 2 flavors of Linux, a premium and a standard. There's just a cost difference, and 2 flavors of Windows. And so we have about 40-some items in our. We have 9 catalogs with 40-some items in them. This tool allows you to create order forms. They call them service dialogues. It uses those very ARM templates that I showed you to deploy the VM. And to extend the capability of the tool, they have an automation model that's pretty neat. This is a Ruby on Rails app, so you have to learn to write a little bit of Ruby, but you can go into the automation model. And a little bit of Ruby is the right thing because I'm not a Ruby programmer. So to extend this, to build a VM like a Windows VM, we have to put 35 additional packages on a Windows VM when we built it. To extend that and make it happen, I wrote the Ruby code, and then they provide you with a state machine in the automation. That's just a workflow. It says do this, then do this, then do this, do this. If one of these fails, try it 3 times. This one, it only has 1 strike and you're out, et cetera, et cetera. So what they're trying is we're having the Ruby code call REST APIs. We wrote the REST APIs using Flask. So CloudForms uses Ruby to call the REST API. The REST API written in Flask either calls Ansible to do something because Ansible can, for instance, use WinRM to talk to the Windows machine, to install a package and tell it to run, et cetera, or to do some configuration management or whatever the case may be. So that's how we've pulled off building it all. And our user logs into CloudForms. They select the catalog item. They fill out the form. The build begins. They get a request ID email. We have a web service to get a server name. It gets submitted to Azure. Then after the Azure is done, then CloudForms does the configuration of the VM. Then there's some generic configuration that happens that's not specific to Windows or Linux, and that's things like putting a billing tag on a NIC or putting a billing tag on the VM, so that when our Azure bill comes in, there's a cost code associated with it. We know how to, what department needs to get charged for that. And I would demo that, but there's no time. We're at the end, and if you want this presentation or send me an email, here's my email address. That's Eroteos. It's a made-up name, but it's kind of cool. It's all letters, so it's easy to tell people that that's your email address. And with that, I'm done.
Thank you, Richard. All right, guys, that's all we have for today. Come back next week and see Derek's talk.
Thanks. Sorry it went long.